All right. As it says right there, graphing the trig functions can actually be difficult. So that's what I'm doing today. I'm going to start with just amplitude and period to see if you can just graph those two. I'll be honest, phase shift is the one that makes things even more complicated. Okay. So for now, we're just going to deal with those two. But over the years, I've come up with some suggestions that really seem to help. And as you can see there, it says to keep your x values one period to the right and one period to the left. What I mean by that is, for example, if we were just doing sine, what is one period for sine? How long does it take for sine to repeat? 360. So do you agree, like, here's the middle. To the right, then, I would say go to 360 for sine. So I said one period to the right and one period to the left. So over here would be negative 360. Now, as the period of your problem changes, you can change that. Maybe it was 180 degrees, then you would put 180 way out there on the right and 180 here on the left, because I said one period to the right and left. Does that make sense? What I'm also telling you to do then is to also keep 4 tick marks to the right and left. So here's 1, 2, 3. See, there's already a 4th one there. All right, so right now, do I have 4 tick marks to the right? Some people fail to see that one, but do you see there are 4? And then pretty much do the same thing this way. And obviously, it'll change from problem to problem, but, you know, then this is 180 and so forth and so on. Now, is this how they're going to ask you to actually graph it as you get further along? No. I will make that change for you when you need it. But I think for right now, doing what I suggest is going to be very, very helpful. Okay? I've figured it out. It seems to work. Probably not going to get taught this way anywhere else, unless somebody listens to my recording and decides to start teaching it that way. So the first thing we're going to do is decide amplitude and period for this particular one I have here. It's y equals sine of 2 theta. So let's figure out amplitude and period. Because I told you, let's not worry about phase shift yet. Let's get this down first. So what is the amplitude for this one? Yes, it is 1. Very good. I like this one because sometimes people forget there is a 1 out there. Right? That is the number out front. And how about period? Well, what's the normal period for sine? 360. And of course, we're supposed to take that normal period and divide by, okay, so the normal period now is 180, which means I will hear that entire song in 180 degrees. So you notice, I believe I've given you the 4 tick marks, correct? So I'm looking at it this way. I know my amplitude is 1, so up here, what number am I going to put? A 1. And down here, I'm going to put negative 1, because again, it's 1 up and down. Kind of like we were told earlier when we refreshed amplitude. What number should I put out here for that tick mark then? If you follow my suggestions, we will put 180 degrees right there. And then out here is negative 180, because what did I tell you to do? 1 period to the right, 1 period to the left. So then what's this one in the middle over here? That'd be 90, very good. Making this one over here negative 90, so forth and so on. I think you get the idea. Once again, so that you kind of have an idea of where this is coming from in case you get stuck with my suggestions, there is never anything wrong with going to a little table and finding out where things are. There is nothing wrong with that. And so in this particular problem, let's maybe make it over here is what I'll do. I can put in theta values and I can get y values. That is something you can always do if you ever get frustrated or stuck. Is it going to take you a little bit longer? Yes. But once you see how this 4 tick mark thing works and a period to the right and left works, I think you're going to speed things up a lot. So what's always a good theta to start with? Yeah, let's start with 0 degrees. Now we know that 0 degrees is right over here, which is 1, 0. Any disagreement with that ordered pair? No. And so I'm saying, basically, though, watch what I'm saying. I'm saying put 0 right there, right? That's what I'm saying. And then I'm telling you to double it. Well, 0 doubled is 0. No big surprise there. And so we take 0. So it's sine at 0. Well, what is sine at 0? It is 0. And so the answer is 0, 0. Any question how I got 0, 0? Well, based on my tick marks, and that's why I have you do this, based on my tick marks here, what's probably a good value to choose next? What's my next tick mark to the right? 45. So let's put 45 degrees in. But that means take 45 degrees and put it right there. Do you agree that's what that means? So I have to take 2 times 45, right? What is 2 times 45? 90. What's sine at 90? Well, where's 90 on this unit circle? Yeah, it's on the top. What's the ordered pair up there? What's sine there? So this is 45 degrees. You agree I just put 45 degrees in. I doubled it because it said 2 right there and got 90. Sine at 90 is 1. So it's 45 degrees, comma, 1. Well, based on mine, what am I going to put in next? Why did I erase that? I have no idea. Now, where am I actually putting 90 degrees? In for theta. So put 90 degrees right there. So it's 2 times 90 is 180. Now it's asking me for sine at 180. So do you see what that number out in front of the angle is doing every time? In this case, it's just doubling whatever I decide to put in. Let's face it, I could put in 10 degrees if I felt like it, but that's not really going to help me with the unit circle. So now if I put 90 in there, you're right. I'm talking about 180 degrees, which means I'm over here, which is negative 1 comma 0, correct? So take sine there. Does that make sense on what we know sine to look like? Not really sure why I switched to green, but that's what it is now. Let's switch back to what would be another good value to put in, or could you take a pretty good guess of what's going to happen at that next location? I think you should have a pretty good idea because I'm hoping that you have a good idea what sine and cosine look like now, at least the graphs. So what is the next value though? It'd be 135, right? Would be my next tick mark, this one right here. But what do I have to do to 135 before I actually take sine according to this problem? Why do I double it? Because it says to take 2 times whatever angle you choose. Again, you could choose any of them. I'm just going by the tick marks I have. And so 135 is right there. 2 times 135 is a very nice 270, which is 0, negative 1. And which of those two values is sine again? The y value. And so it's negative 1. And I think we all know what's going to happen at 180. Why does it come back to 0? Because I put 180 in, I have to double it, which is 360. Sine at 360 is the exact same thing as sine at 0, and so it will end up here. Now, some of you might say, or at least I'm hoping some of you are saying, isn't that exactly what happened when we did I guess you could call it the parent graph for sine? Isn't that exactly what happened? So you might be saying, why is this different? The reason this is different is what if I asked you to go all the way to 360 and I didn't let you stop at 180? And that's the problem. Most of these schools, if you go on, are going to ask you to go all the way to 360. And all that's going to happen is you're going to make that same thing again and just keep going out. And so did you technically hear the song twice in 360 then? Well, technically you did. But do you see how this makes it way easier? And now that you have knowledge at negative 45, you could keep doing it, but where's it going to go? At negative 45, where's it going to be? Yeah, it's going to be down here. How about negative 90? Where's that going to go? Yeah, right there. Back up here, back down there. That's why I teach it that way. That looks almost the same as the sine graph you had before. Okay? That's horrible, but you get the idea. Now, if I did ask you to go all the way, here's the only thing that would happen. Realize, do you agree that's basically the portion, whoops. Do you agree that's the portion of the graph I made you graph just now is just that? If I made you go all the way, all you would do is just sit there and do it again, right? I mean, it doesn't really have to be, well, hopefully yours looks better than that, but it doesn't have to be rocket science here. I'm asking you to use the tick marks that we know, one period to the right and left, and did you see how much easier that was to do it if it was just one to the right, one to the left, 4 tick marks? Why 4 tick marks? That's why. Because then you can keep sitting those 4 easy spots. Because you know what these graphs look like. You have a good idea. Even if I switch to cosecant right now, you know you'd be looking for those parabolas up and down. You know that now. Same thing with tangent. You know what it looks like, at least in general. So any questions? So what's slightly different about this one? Well, the very first thing is that it's cosine, right? Another thing is that the amplitude is 2. Is the period a little different in this one? Yes, it is. Let's see what we can do. So let's first just figure out these two, because phase shift, remember, we're dealing with that later. Amplitude is 2. So before I even go any further, couldn't you just kind of do this if you felt like it? This is 2. That's negative 2, right? Now we have to figure out which each of these tick marks is going to be. How about cosine? What's its normal period? 360. And divide by 4, because I'm supposed to hear it 4 times. And so you divide that out, and well, yeah, that's pretty small, isn't it? What does that mean then, based on my suggestions? Again, you don't have to follow my suggestions at all. But I think it's going to be easier if we're all kind of doing the same thing. That means out here I should put what? 90. And way out here I should put negative 90. And then it might help you just to get another one in there, so negative 45, right? I notice how I always pick the one kind of in the middle there. Could you go ahead and write all those tick marks in if you wanted to? Yeah, you can probably write a little smaller than I can right now. So if you want to sneak those in there, that's fine, because what would this one be, out of curiosity? Yeah, you see how that'd be 22.5? So I don't want to sit here and write them all in, but if you want to put in a few, that's fine. Maybe I'll write one more just in case you're a little confused. Anybody got that one? It'd be another 22.5 over, so I'm at 60. Okay. Now, do those degrees look absolutely horrible if you had to go graph them? Because those degrees right there, they're not on the unit circle, are they? 22.5? That's not on there. 67.5? That's not on there. It's 45? Yeah. Is it a nice value? No. 90? That's not too bad. So then how come I'm having you use those for? I thought that it was supposed to come out to those nice divisions. Because what do you have to do to the angle before you actually take sine or cosine in this problem? You got to take it times 4. Do those end up being nice numbers? Yes, they do. So why don't you go ahead and try this one on your own, because I have to stop the recording now.